Hello and welcome to this clip having a look at a couple of applied PV equals nRT exam style questions. So first of all, with this one, they want you to calculate the gas pressure, so that's where you start. You need to rearrange PV equals nRT so that P is the subject. So the next thing to do is to look at the two values that need to be converted and to convert the units where necessary. So degrees Celsius needs to be in Kelvin and decimeters cubed needs to be changed to meters cubed. Then they give you some data about the N2O gas, but obviously grams is no use to you. You need to convert that into moles. So you do that, and then you can pop everything into the equation. So this gives you this value in pascals for your pressure. That's your calculator value, but they want you to give your answer in standard form to three significant figures. So you simply convert that across as 4.46 times 10 to the power of 6 pascals. So having a quick look at the mark scheme, you can see that if you got that far, that would get you 4 marks straight away. If you didn't, then there's other ways in which you could get the marks. So you can follow the actual marking scheme through and double check, is there any possibility of error carried forward? So the next question is the other type of PV equals nRT question, where they use PV equals nRT to work out the molar mass and therefore the molecular formula of a compound. So it tells you that an alkene D is a liquid at room temperature and it can be easily vaporized, at room temperature and pressure. Now be careful, because although they're talking about room temperature and pressure, that doesn't automatically now mean it's a V equals 24N, because it gives you quite a lot of information about D, a lot of data. So they want you to determine the molar mass, and this suggests finding N in PV equals nRT. So the first thing to do is to rearrange PV equals nRT so that N is the subject. I'm choosing N because N is related to molar mass by moles equals mass over molar mass. So look at the information you've been given. You've been given 82.5 centimeters cubed and 101 kilopascals. 373 Kelvin is already in the correct format, so I haven't highlighted that. So I need to convert my volume and convert my pressure. So it's 8.25 times 10 to the power of minus 5. You could just as easily do 82.5 times 10 to the power of minus 6. So then you calculate the number of moles by inserting the converted values you've just come up with. And like I said, there's no need to convert temperature as it's already provided in Kelvin. So I can keep my calculator value, and I'm going to use this to determine the MR of alkene D. So that gives me 70 grams per mole. The last thing to do is to make that fit the general formula of an alkene, which is CnH2n. So with a bit of playing around, it's quite easy to come up with C5H10. Okay, I hope this has been useful. Let's have a quick look at the mark scheme to double check, and you can see that 1 mark is for the actual C5H10, and the rest of the marks are for getting 70 grams per mole. Okay, thank you for listening. Until next time, see you soon.